Hey folks, this is Captain Jones here to talk to you about the control unit for the LC3. This is the first unit or first lesson in Unit 4. So we're going to start to look at how exactly we implement this control unit to finish the last part of making our LC3 work. Our objectives today are twofold. We're going to take a look at the state diagram that implements this control unit, and hopefully by the end of this lesson you'll be able to just describe how that state diagram is depicting the fetch and decode phases of the LC3 instruction cycle, and 13 of the 15 instructions. We'll save 2 of them, the last 2 for a later lesson. And then additionally, we've done this a little bit, but I want us to be re-familiar with 19 of the 42 total control signals that our control unit makes. So if you dive into Appendix C, you'll start to see that that we are implementing this control unit here. So this is actually the diagram, I think, from the end of chapter 5, which is sort of the last time we looked at our data path, or maybe the end of chapter 9, because we've got some input-output stuff here. But it's this box here, this control unit, that is the subject of this whole unit, pretty much this whole appendix. And as you dive into Appendix C, you'll see that this control unit is set up so that it takes a couple of inputs, right? So we have some portion of our instruction register, our branch enable signal that are kind of coming into our finite state machine, our control unit. And then this finite state machine produces a couple signals that effectively amount to the current state of the system. We'll look at these a little closer more later on. And 42 control signals that go back to the rest of the LC3 to control what's going on in our computer. And so you can see on the right hand side here, this is the complete list, table C.1, the complete list of 42 control signals. What I've done here, kind of in red, are marked the ones that we should be familiar with. There should be 19 of them here in this list, marked with red, that amount to 19 different control signals that we have already seen on our data path. And on the right hand side, the table here kind of shows you the different values. The one thing I'll mention is that not quite actually on this diagram, but we have mentioned it previously, are that the destination register and SR1, source register 1, are sometimes not the same, not specified in the instruction register. So you'll notice here that we have a DR mux and an SR1 mux, which aren't explicitly listed or depicted on the data path. And a couple different values, because those might take on some different values based on which part of the instruction cycle kind of we're in. And then in Appendix C, we get our first look at this big old state diagram that defines our control unit. So you can see kind of starting at the top here is our these first 5 states are fetch and decode, and so I'll help you kind of decipher this diagram really quick so you can start to look at it and understand what it's doing on your own. This box at the top is where we always initiate our fetch cycle. So you can see here that the memory address register is getting the value of the program counter. The program counter is being incremented, like we know happens on the very first clock cycle of the fetch phase. We are testing for ACV, which is our access control violation. We'll see in a future lesson how we do that. Just recall for right now that if the value in the memory address register is in privileged space or supervisor space, and we don't have that privilege, then there's an access control violation. And then right here in brackets, we're testing our interrupt signal. If there has been an interrupt, then we're going to branch down here to a different state to be able to process that interrupt. And as long as there isn't an interrupt, then we will figure out if we can access the memory location we're trying to access. If there is an access control violation, we'll branch somewhere else to deal with that. And as long as there's not an access control violation, we'll move on to this state here, where our memory data register gets the value that's in memory at the value specified by the memory address register. And you can see this little backwards arrow here because our memory, recall that it produces this ready signal. So, memory typically takes a lot longer to access than just the instruction cycle. So it's possible that our memory might take multiple clock cycles to be able to access that. So we're going to wait here in this state until the ready signal is given, at which point the instruction register is loaded with the value in the memory data register. That will be our next instruction. And then finally we get to our decode phase. And then from this decode phase, you can start to see all of our instructions. Our state diagram kind of branches off into any number of different branches. based on the value in the four most significant bits of the instruction register. So this would be the 4 bits of our opcode. And so that's kind of how the state diagram is laid out, right? I've got, anytime I'm testing a signal, it's in brackets down here, and then I've got a 0 or 1 transition. And you can see hopefully down here all the different operations of our LC3 computer, given this sort of kind of pseudo register transfer notation, where I have a register on the left, which is getting some value on the right of an arrow. So that's really what's going on here. We're going to spend the rest of Unit 4 talking about how this control unit is able to implement this large state diagram, and then also talking about the other half of these control signals, which are basically pertinent to how we process the interrupts and the trap routines that we talked about in Unit 3. I would encourage you at this point to make sure you're familiar with the 19 control signals that I've got marked here. And if the video is moving by too fast and you can't see those, then let me know. I can provide those to you. Make sure you're familiar with these control signals, that you know what they do and what they're used for. So, for instance, maybe the DR mux is a little new to us. Make sure you are kind of aware, when we might need these different values, or the SR1 mux, when we need these different values. And then also take a look at this state diagram. We talked through the first couple of states, and hopefully I showed you how these first 5 states are implementing the fetch and decode phases of our instruction cycle. Go through the rest on this diagram and make sure that you are kind of confident that you know how this state diagram is depicting the how each of these other instructions, 13 of the 15 that we know so far, are being implemented. And then in a future lesson, we'll actually talk about how this all comes together in the hardware. All right, folks, that's all I got. I'll see you next time.